Welcome to The Explainer. I'm absolutely thrilled you're here today because, well, we've got some genuinely fascinating AI news to unpack. We're looking at a system called AnovaX. It's a radical, local-first Python voice assistant that completely reimagines how we do desktop automation. If you've ever felt boxed in by the limitations of mainstream voice assistants, the ones that just don't quite get custom workflows, you are going to love how this project puts the control right back in your hands. Okay, let's dive into this. The core dilemma with today's voice tech is, frankly, a massive lack of user control. Think about how traditional cloud assistants actually work. They take your raw audio, ship it entirely off your device to some remote server, and then they lock you into a highly curated, fixed set of skills. You're completely at the mercy of the cloud provider. But AnovaX, it flips the script entirely. It runs as a local Python process, it gives you dynamic desktop automation, meaning it actually talks to your OS applications, and most importantly, it keeps all your sensitive voice data securely on your device. It's a total paradigm shift. So here's our game plan for today. First, we'll talk about rethinking voice assistants. Then we'll break down the AnovaX architecture, followed by typed agents and execution. After that, we'll look at the adaptive recovery loop, explore remote transparency, and wrap up with exactly why all of this matters so much. All right, let's jump straight into Section 1, Rethinking Voice Assistants. I want to share a quote straight from the archive paper because it establishes the exact problem developers are trying to solve here. Quote, desktop voice assistants are still dominated by cloud pipelines that ship raw audio off the machine and expose a fixed set of skills. End quote. I mean, if you're trying to build custom workflows or manage highly sensitive data, asking Siri or Alexa to handle it, that's just not going to cut it. We need something that can interact with arbitrary desktop apps without blasting private audio out to the open internet. And honestly, the solution to this huge problem is so elegant, it kind of blew my mind. The entire thing, the whole shebang, is just a highly comprehensible, few thousand-line Python codebase. There are no massive server farms required here. It literally treats your local desktop as its primary action surface, processing speech, planning its next move, and executing actions all within one bounded local process. Next up, Section 2, the AnovaX architecture explained. Let's see how they separate the planning from the execution. To really get how this pipeline flows, let's use a brain and hands analogy. Step 1 is the wake word and speech pipeline. That's what grabs your voice. Step 2 is the Gemini planner. This is our brain. But here's the kicker. The brain doesn't just spit out raw text. It outputs a highly structured JSON clan, filled with tool calls. Then Step 3 is a safety layer that carefully inspects that JSON. And finally, Step 4 is the multi-agent orchestrator. These are the hands that actually carry out the instructions. Let's zoom in on that third step, the whitelist and deny list safety layer. This is absolutely crucial because it acts as a hard security boundary. By intercepting those JSON tool calls before anything actually happens, the system ensures the underlying large language model never ever directly touches your OS, keyboard, or input devices. And why is that a big deal? Because it strictly prevents prompt injection attacks from maliciously hijacking your system inputs. If you want a custom tool to bypass that deny list, you have to explicitly register it yourself. Moving right along to Section 3, Typed Agents and Execution. Time to meet the workforce. Now, what's really interesting about this slide is how the core engine translates that JSON into real-world action. Instead of one big, messy script, we have a specialized workforce. An app agent launches your OS applications, a typing agent handles typing into active windows, a browser agent does your web searches, but check out that safeguards column. These specialized classes don't just run wild. They operate safely within a bounded thread pool. That means if multiple calls come in, they queue up nicely instead of spawning an endless nightmare of processes. Each agent has strict timeout settings, shared resource locks, and retry policies. This makes sure they never break your system state. But you might be wondering, what happens when you ask it for something super complicated? Well, enter the meta agent. This is a recursive agent that lets the planner delegate subgoals right back to itself. So if you throw a really complex, multi-step workflow at AnovaX, it doesn't need to phone home to some external orchestrator to figure it out. The meta agent just naturally breaks that massive goal down into bite-sized, actionable JSON chunks for the other agents to handle. Now, hold on, because recursion in software can be a massive headache, right? You don't want an endless loop. And that's exactly why the developers instituted a hard limit, 2. That number 2 is the hard-capped recursion limit for the meta agent. It's an absolutely necessary architectural constraint to completely prevent the AI from getting stuck in an infinite self-delegating spiral forever. If you've got sub-goals nested deeper than 2 levels, you're going to have to manually flatten them. It's just a brilliant, pragmatic way to balance raw capability with actual system stability. Which brings us to section 4, the adaptive recovery loop. Because let's face it, things go wrong. Instead of just crashing or throwing an annoying error code when things inevitably hit a snag, AnovaX uses a really robust adaptive recovery loop. It triggers the split-second to core step fails. It fires off a compact React-style prompt to analyze exactly what went wrong in that failure state, and then it determines the best possible next action. This allows the assistant to gracefully bounce back from single-step failures entirely on its own. It just makes the whole automation process so much less brittle. And this brilliantly illustrates how they tackle the user experience. Looking at the archive abstract, they note that the system, quote, hides Gemini's latency behind speculative execution of read-only tools, end quote. Because, calling an LLM planner takes time. So AnovaX cleverly runs safe read-only tools speculatively while it waits for the brain to respond. It's a fantastic trick to keep the interface highly responsive during those network inference delays, ensuring your experience doesn't just stall out and leave you hanging. All right, let's look at section 5, remote control and transparency. So how do you interact with a headless system like this from afar? The devs solved this by including a companion Flask server that runs locally right over your own Wi-Fi. It gives you this super clean, phone-friendly remote interface. From your phone, you get real-time mirroring of every single agent lifecycle event. You literally see what the brain is planning as it happens. Plus, it gives you a live MJPG stream of your laptop screen. You could be making coffee in the kitchen, trigger a command from your phone, and watch it execute securely on your laptop via that live stream. How cool is that? What this means is you get full transparency into the agent state, all without granting the LLM direct, unchecked keyboard control. But quick side note, actually a really important note. This Flask server requires local network access, and it exposes that live screen stream. So it is meant strictly for trusted local networks. You absolutely should never route this over the public internet. But keeping it local like that just proves their deep commitment to on-device security and user transparency. And finally, section 6, why this matters. Let's pull it all together. AnovaX is incredibly significant because it proves, without a doubt, that a local-first assistant can actually match the functional scope of massive cloud services, but with 100% privacy. The codebase itself prioritizes readability and easy modification over just raw throughput. It's built so you can actually inspect and tweak it. Plus, the JSON-based planning perfectly aligns with standard tool use frameworks. That means swapping out the Gemini planner for a different model or dropping your own custom executors into the Fred pool is super straightforward. Ultimately, it serves as a highly adaptable local-first template for handling all those annoying transient desktop failures we deal with in AI automation. So, I want to wrap up our explainer today by leaving you with this provocative question to chew on. How will you use typed agents and adaptive recovery in your own local automation stack? The architecture that AnovaX lays out is just a massive leap forward for keeping our data local while making automation significantly smarter and more resilient. I highly recommend checking out the full ARV side paper to dive into the complete execution logic. Thanks so much for hanging out with me today to explore this incredible tool. Stay curious and keep building.